Hello, welcome back. We are video 8. This is video 8 back to Z transform. We are going back to Z transform. Let's look at our material. I think this example has been done on the WhatsApp group and somebody has gotten the answer. Maybe I should just use this opportunity to explain it. Let me go up again. We have done, I'm sure we have done example 3.1.3, and then let me take this, even though it has been discussed on the WhatsApp group, let me take it afresh. We are giving x of n, equals minus alpha n u of minus n minus 1. The book is generous by telling you the implication. The book is telling you that it is actually equal to 0 when n is greater or equal to 0, and it is equal to minus alpha n when n is less than 0. Now, let's come to the board. This is what we are given. It has been written on the board. The book is generous by telling you the implication. Now, hello, let's take it one by one. U of minus n minus 1. Set minus n minus 1 to be equal to 0. Minus n equals 1. N equals minus 1. We are not saying that n is equal to minus 1. We are saying that whatever is used to be at 0 will now move to minus 1. So let us draw u of minus n. U of minus n, you remember, we start from 0, minus 1, minus 2, minus 3. It will be 1, 1, 1, 1. And that trend will continue this way. At 1, it's going to be 0. At 2 is going to be 0, at 3 is going to be 0. That trend continue. This is n. This is u of minus n. If we are now giving this, that means it is still going to be like this, except that instead of starting at 0, it will start at minus 1. So if I want to draw that now, so this will be n. At 0, it's going to start at minus 1. That's shifting. So this will be 1, 1, 1, 1. This trend will continue this way. This will be minus 2, minus 3, minus 4. Somebody on the WhatsApp is still including 0. You don't include 0. This is what this is going to be. That is u alone. Hello. That's u alone. We have minus alpha. We have minus alpha n. Minus alpha n, which will be like this. It will have been minus this will be again, it will have been, if this is 0, it will be alpha minus alpha raised to power 0. If this is minus 1, it will be minus alpha raised to power minus 1. If this is minus 2, it will be minus alpha raised to power minus 2. If this is minus 3, it will be minus alpha raised to power minus 3. If this is minus 4, it will be minus alpha raised to power minus 4. Sorry about the height. I don't bother about the height. I know it's going to be negative. That's why I'm drawing it down. At 1, this will be minus alpha raised to power 1, minus alpha raised to power 2, minus alpha raised to power 3. What you are giving here is like this multiplied by that. It is like this multiplied by that. It is like this multiplied by this. What will now happen? Because from 0 to 1 to 2 to 3, we're having 0 here. It will be like 0 times this will give us 0. 0 times this will give us 0. The implication of this is that in the final analysis, the sample at 0 to this place will disappear because they have been multiplying by 0. So that's why the overall, that is why the overall signal will now be like this. Let me draw it on top here. N at -1, -2, -3, -4, -5. I'm going to be having this. This will be alpha raised to power -1 minus alpha raised to power -2 minus alpha raised to power -3 minus alpha raised to power -4 minus alpha raised to power -5. This trend will continue that way. But on this side, where we have 0, 1, 2, 3, we are going to be having 0. Why? Because we are multiplying 0 with this at 0. That will give at 0, this 0 times this, that will give us 0. At 1, 0 times this, that will give us 0. At 2, 0 times this. So it's like this portion will be cut away. So this is what we are going to have. Hello, let me come again. We broke this expression down into 2. It is like this times this. This is what is drawn here. This is u of minus n minus 1. And this minus alpha n. When you multiply by 2, when you multiply these 2, you are going to get minus alpha n u of minus n minus 1. This is the graphical interpretation of that. Hello, I started from here. U of minus n. U of minus n minus 1 will be this. One signal can be turned to become another signal just by simple operation. This is u of minus n. It starts from 0. It is 1, 1 this way. This is u of minus n minus 1. It will not start at 0. It will start at minus 1. It will go like this, just like that. And this minus alpha n, it looks like this. When we multiply these two, we are going to get this. So now, I am just on a journey. This is just my on the way. I will now remove this. I will remove this. I've used them to get that. I've used them to get where I am going. This is where I am going. And that's what he has told you by this formula. That when n is greater or equal to 0, this thing is going to be 0, 0, 0. When n is less than 0, this thing is going to be simply minus alpha raised to power n. Now, Z transform tells you that x of z equals sigma n equals minus infinity to infinity x of n z raised to power minus n. So let me start from minus 1. If n is minus 1, I'm going to have what? I'm going to have, if n is minus 1, I'm going to have minus alpha raised to power minus 1, z raised to power minus minus 1. Again, if n, I'm talking of n equals minus 1 now. If n is minus 1, the value of it is minus alpha raised to power minus 1. And the z is going to be raised to power minus n. Whereas n is minus 1. That's why I'm having minus minus. Let me move on. Let me move on. Let me move on to n equals minus 2. If n is minus 2 now, what am I going to have? The value here is minus alpha minus 2 z raised to power minus minus 2. Let me move on to minus 3. This will be minus alpha minus 3 z raised to power minus minus 3. Let me move on to minus 4. Minus alpha raised to power minus 4 z minus minus 4. I can continue that way to minus 5, to minus 6, to minus 7. But let me stop here. On this side, if n is 0, x of n is what? 0. So that will disappear. It will be like 0 multiplied by z raised to power 0. When n is 1, it will be like n of at 1, the sample is 0, 0 raised to power minus 1. I'm supposed to say plus. Plus, when n is 2, this will be 0, 0 raised to power minus 2. And I can continue like that. But the ones here, since they are 0, 0, 0, they will be 0. I can as well remove them. I can remove them. So, this is my x of c equals this. Let me rewrite it. X of z will actually be what? Minus alpha minus 1, 0 raised to power 1. Minus alpha minus 2, 0 raised to power 2. Minus alpha minus 3, 0 raised to power 3. Minus alpha minus 4, 0 raised to power 4. And that's supposed to continue. This is a GP. This is a geometrical progression. And from what you are seeing, the first term, T1, is minus alpha minus 1z. And the common ratio is going to be alpha minus 1z. How do you get the common ratio? The common ratio is just simply T2 over T1. What is T2? Minus alpha minus T square. What is T1? Minus alpha minus 1z. If you divide this, minus will cancel minus, you are going to have plus. Alpha minus 1, alpha minus 2, it will remain alpha minus 1 on top. Z2, it will remain z on top. So that's how to get to your common ratio. If you like, you can make it T3 over T2. T7 over T6. Take a term, divide by the previous term. That's your common ratio. Then, but we remember, sum to infinity of a GP. Sum to infinity of a GP is going to be s to infinity, which is T1 over 1 minus r. T1 is what? Minus alpha minus 1 z over 1 minus r is what? Alpha minus 1 z. You can multiply up and down by, you can keep it like that if you like, that's your answer. Or you can multiply up and down by alpha. This can give you z over alpha minus z. If you multiply this by alpha, alpha minus 1 will disappear. Multiply this by alpha, this will be alpha. Multiply this by alpha. So either you write this or you write that. Both are correct. Region of convergence, ROC. The condition is that R must be less than 1. R must be less than 1. R must be less than 1. You remember our R is this, which means alpha minus 1, Z must be less than 1. This is like Z over alpha less than 1. This is Z less than alpha. Z less than alpha. How do we draw this? To draw the region of convergence, this is the real axis, this is the imaginary axis. Draw a circle with the center at the with the origin at the center. Let the radius be alpha. Z must be less than alpha. So the region of convergence is inside this circle where C is less than alpha. So this is the ROC. Inside here is the ROC. So this is the Z transform, this is the ROC. So with that, we have come to the end of that example. Let's stop the video here. We continue at video 9. Continue at video 9.